Today, we're diving into something that sounds a lot like science fiction, but it's happening right now, teaching computers how to read our brains. Well, not our thoughts exactly, but the incredibly complex electrical language our brains are speaking every single second. And it turns out, AI is the key to finally understanding it. Let's get into it.
You know, your brain, right this moment, is a storm of electrical activity. It's like this non-stop, super complicated conversation happening inside your own head. So how do we listen in? Well, for decades, our main tool for eavesdropping on that chatter has been the electroencephalogram, or EEG. It's really our window into what the brain is actually doing. Okay, so we have this window, but here's the catch. Looking through it is one thing, but actually understanding what you're seeing, that's a whole different ballgame. And for us humans, well, reading these brain signals is a massive, massive challenge. So just so we're all on the same page, an EEG basically works by putting these little metal discs on your scalp to listen in on the brain's electrical rhythms. It's been a foundational tool in neurology for a very long time, especially for diagnosing conditions like epilepsy.
And this is where we really get to the heart of the problem. Reading an EEG, it's not just staring at some squiggly lines on a screen. No way. It's an incredibly demanding mental puzzle, and it takes years of specialized training to get good at it. Why? Because the signals are messy, they're full of interference, and your brainwaves look totally different from mine. All of this can lead to different doctors seeing different things, and sometimes, tragically, even misdiagnosis. The stakes couldn't be higher.
So if our own human eyes and brains have their limits, where do we turn? Well, this is where artificial intelligence comes in, and specifically a really powerful type called deep learning, which is proving to be a total game changer. Let's break this down real simple. With old-school machine learning, you have to spell everything out. You tell the computer, okay, a car has 4 wheels, it has doors, it's this big, you get it. But deep learning, it's completely different. You don't give it rules, you just give it a mountain of examples. You show it thousands and thousands of pictures of cats, and it figures out for itself what makes a cat a cat. It literally teaches itself. So now, you just swap the cat pictures for brain signals. That's exactly what's happening. Researchers fed an AI a massive data set. We're talking over 30,000 EEG recordings that were already checked and labeled by human experts. And just like with the cats, the AI started learning, spotting those tiny, subtle patterns that separate normal brain activity from the abnormal. Okay, the theory sounds amazing, right? But what does this actually look like in a real busy hospital? Let's walk through the workflow and see how this technology is actually being used right now. Well, the whole process gets a huge efficiency upgrade. An EEG is recorded, and the AI is working in the background, immediately giving a first pass. It flags which studies look normal and which ones look abnormal. This lets clinicians prioritize their work, sort through the findings, and get a final report done way, way faster. So imagine you're the doctor. Instead of staring at this long, overwhelming list of patient recordings, you get this, a dashboard. You can see your entire caseload at a glance, with color codes showing which cases are probably fine and which ones need your attention now. It's basically triage, but for brain data. And it gets even more detailed. It doesn't just flag a whole recording. Let's say you have an EEG that runs for 24 hours. The AI will go in and pinpoint the exact moments, the specific seconds that look suspicious. It's like having an assistant tapping on the screen saying, hey doc, you really ought to check this part out. It guides the expert's attention right where it's needed. So how much of a difference does this really make? Get ready for this number. For those long 24-hour EEG recordings, this AI can reduce the time a human expert needs for review by a factor of 50 times faster. That's not just a small improvement, that is a complete revolution in how this work gets done. Now, I want to be really clear about something. This is not about replacing doctors, not even close. It's about empowering them, giving them a superpower. This is all about creating a powerful partnership between human expertise and machine intelligence. Let's look at just how good this partner is.
First number, 95%. That's how accurate the AI is at that crucial first job, simply telling the difference between a normal recording and an abnormal one. It's an incredibly reliable first filter.
Next up, 88%. That's the AI's overall accuracy in identifying and classifying all the different kinds of abnormalities. And what's wild is that clinical studies show this performance is right on par with human experts, and in some cases, it's even a little bit better. And this chart just lays it all out for you.
The numbers are strong across the board. Accuracy is high. Sensitivity, that's finding the problem when there is one, is great. And specificity, correctly saying everything's fine here, is also really high. These are solid, proven metrics.
But numbers are just numbers. What do the doctors who actually use this think? This quote from Dr. Harold Arlian really hits it home. He says he thinks of the AI as a colleague who is always looking over my shoulder. A colleague, not a tool, not a piece of software. That one word says everything.
And Dr. Ram Mohan Sankareni says the same thing, calling it a reliable colleague that can provide a second option. You see that theme? It's about teamwork. And why does that matter so much? Because it leads to faster, more accurate help for patients. That's the ultimate goal.
Okay, so the tech is powerful. It's here, and it's working. So where do we go from here? The next big chapter is all about building even deeper trust and making sure this technology is absolutely rock solid and safe.
And that really boils down to two key goals. First, the AI needs to be interpretable. That means it can't just be a black box. It has to be able to show a doctor why it made a decision. And second, it has to be robust, which just means it works reliably for everyone, everywhere, a child in one hospital, an elderly patient in another.
Nailing these two goals is what will take this from being an innovative new tool to just a standard of care. It's how you build real trust, improve patient safety, and pave the way for AI to become a totally routine part of diagnostics.
And this brings us to what is maybe the most important point of all. The AI is a partner, an assistant, an incredibly smart co-pilot, but the human is still the pilot. The final diagnostic decision will always, and should always, rest with the trained, qualified healthcare professional.
So that leaves us with a pretty incredible question to think about, doesn't it? As AI stops being just a tool and truly becomes a trusted colleague in the clinic, what new frontiers are we going to be able to explore? What will this amazing team of human and machine achieve together?